Last time we looked at the polar equation r equals to 1 plus sine theta, and the question was sketch the graph of that equation, and we said that it's enough to sketch the graph of this equation by over the interval from 0 to 2 pi, because sine theta is periodic with period 2 pi. And we did that. We came up with the graph, and the graph looked like this pink curve. And then what did we do? Well, we said find the slope of the tangent line to the graph of this polar equation r equals to 1 plus sine theta at the point where theta is 0. And in the picture we can see where theta equals to 0 is. I get the point 1, 0, right? Because when theta is 0, if I look at the polar equation, I can express the polar equation as a parametric curve by taking x to be r cosine theta, r sine theta, and replacing r by 1 plus sine theta. And we did that, and we got that the polar equation is equivalent to this parametric curve. X equals to cosine theta plus half sine 2 theta, y is sine theta plus half minus half cosine 2 theta. Of course, we did some work there to come to that point. And then, because the polar equation is equivalent to this parametrized curve, now I'm asking what's the slope of the tangent line at the value at the point where theta is 0. I can answer that by using the curve. So, but for the curve, we know a formula for the slope. What's the slope? The slope at theta is given by dy d theta over dx d theta. We computed dy d theta dx d theta. We got a formula for the slope m of theta. Once I find the slope m of theta, I'm going to replace theta by 0. That's going to give me the slope of the tangent line at theta equals to 0, which we got to be 1. We also have to know what are the x, y coordinates of the point at theta equals to 0. Well, when theta equals to 0, I can read off what x and y is, right? When theta is 0, what is x? When theta is 0, x comes out to be 1. When theta is 0, y comes out to be 0. So I get the point 1, 0 in my the point corresponding to theta equals to 0 on the curve is 1, 0. 1, 0 are the rectangular coordinates. So what's the equation of the tangent line at 1, 0? Well, the equation of the tangent line, we can use the point slope formula and say it is y minus 0 equals to slope times x minus 1, right? And we are done. That's what we did last time, right? That's where we finished last time. Now, I want to answer one more question regarding this curve. If I look at the graph of this polar equation, this pink curve, I want to know what are the points where the tangent lines are horizontal. At what points do I get horizontal tangents? Well, how do I answer that? Well, I get horizontal tangents at the points where the slopes are 0, right? So I look at the slope. I solve for the values of theta between 0 and 2 pi. Remember, we restricted theta between 0 and 2 pi when we drew the graph of the polar equation, because that suffices. Now m of theta is 0. So that means dy d theta over dx d theta is 0, right? Because m of theta is dy d theta over dx d theta. When will this ratio be 0? This ratio will be 0 when the numerator is 0, but the denominator is non-zero, right? If both of them are 0 at the same time, then the ratio is undefined, right? Okay. So when the denominator when the numerator is 0, the denominator is non-zero, that's when I get horizontal tangents. So what do I do then? Well, I want to solve what is dy d theta. Dy d theta, remember we found out last time, and I'm just plugging them in. Dy d theta was cosine theta plus sine 2 theta. So this is this quantity here is dy d theta, and this quantity here is dx d theta. So I want dy d theta to be 0, I don't want dx d theta to be 0. Okay, what do I get then? Well, let's solve dy d theta equals to 0. So let's solve this guy. Let's first solve when is dy d theta 0. So dy d theta is 0 means cosine theta plus sine 2 theta is 0. Okay, how do I solve for theta then? Cosine theta plus sine 2 theta is 0. How do I solve for theta? Well, you see that sine 2 theta, you apply the double angle formula for sine, you get 2 sine theta cosine theta, and then you factor out cosine theta. Now you are going to factor out cosine theta, and if you factor out cosine theta, you get cosine theta times 1 plus 2 sine theta. From there, you're going to say cosine theta is either 0 or 1 plus sine theta is 0, right? Sorry, 1 plus 2 sine theta is 0. So that means you're going to get sine theta to be 0 or sine theta would be negative half, right? Okay, for what values of theta is cosine theta 0? Between 0 and 2 pi. Pi over 2 and 3 pi over 2. So I got pi over 2 and 3 pi over 2. Why am I writing 3 pi over 2 in red? Because 3 pi over 2, when you look at dx d theta, right? When you look at dx d theta here, when theta is 3 pi over 2, dx d theta becomes 0, right? So that's why I'm going to exclude that. Now sine theta is negative half for what theta? Sine theta is negative half for what theta? Well, sine theta is negative half, so that means theta has to be in what? The third or the fourth quadrant. And it will be a multiple of pi over 6. It will be either 7 pi over 6, 5 pi over 6 would be in the second quadrant, so its sign is still positive. So 7 pi over 6 and 11 pi over 6, those are the angles where sine is negative half. Okay? And once again, if you were in Calc 1, in my section I gave you the unit circle with all the coordinates and so on, and you can find it out from there as well. But I'm not going to say anything more. If you have more questions on how to get 7 pi over 6, 11 pi over 6, come by my office, I'll do that. Okay, now, so 7 pi over 6 and 11 pi over 6 looks like what I have in my picture. Okay? Is everybody okay? Does anyone know where pi over 6 is? Pi over 6 would be here, right? This would be pi over 6, right? And what would be 5 pi over 6? 5 pi over 6 would be here, right? What are the coordinates of the unit circle at pi over 6? It is root 3 over 2 and a half, right? So what are the coordinates of this point? Negative root 3 over 2 and a half, right? Y is still positive. What are the coordinates of this point? Negative root 3 over 2, negative half. What are the coordinates of this guy? Positive root 3 over 2 and negative half. Okay? So sine of theta is negative half where? 7 pi over 6 and 11 pi over 6. Well, I lied when I said I'm not going to go over the reasoning why you get those angles, but this is why you get those angles for sine theta equals to negative half. Okay, so that means there are three points on the graph of the polar equation where the tangents are horizontal. What are the points? Let's go back to the curve. Let me use black ink. I get this point, right? This was pi over 2. And clearly at pi over 2, I have a horizontal tangent. What else? I got the point 7 pi over 6 right here. This is the point 7 pi over 6, and this is the point 11 pi over 6. So there I have horizontal tangents, right? Clear? Can you imagine where the vertical tangents are? Yeah, let's see if that's the case. Well, I'm not going to probably go over the detail here. Okay, now let me say, so far I found only the values of the values of theta where I get horizontal tangents, right? How about vertical tangents? What do I do? To find the horizontal tangents, what did I do? To find the horizontal tangents, I found out where dy d theta is 0 and dx d theta is non-zero, right? To find vertical tangents, what are you going to do? You're going to do the opposite. Very good, yes. Vertical tangents. What you're going to do is you're going to solve for dx d theta is 0, and you want dy d theta to be not 0. Okay? Am I making sense? And what was dx d theta? Dx d theta was negative sine theta plus cosine 2 theta, right? Am I making sense? And how would you... okay, let me write down that. Negative sine theta plus cosine 2 theta. Negative sine theta plus cosine 2 theta. And what is dy d theta again? Cosine plus sine 2 theta, right? Don't want that to be 0. Now, how would you solve? How would you solve this equation here? How would you solve that equation? You have a negative sine theta. What did you do with cosine 2 theta? Those of you who took Calc 1, when I reviewed trigonometry, I gave you a problem where you had to solve something like this, okay? What did you do with cosine 2 theta? Well, you're going to convert that into sine. So what is that? Cosine 2 theta is the same as what? No. Cosine 2 theta is 1 minus sine squared of theta. Sorry, 1 minus 2 sine squared of theta. That's cosine 2 theta. Okay? Now what? Now you're going to rewrite this. I'm going to write negative 2. Let me write it here. Negative 2 sine squared of theta minus sine theta plus 1 equals to 0. Or let me multiply both sides by a negative. I'm going to get 2 sine squared of theta plus 2 sine theta minus 1 equals to 0. Now think of this equation, think of sine theta as x. Then essentially what you have here is 2x squared plus 2x minus 1 equals to 0. You have a quadratic equation. You can solve for x, either factor it out or use the quadratic formula, right? So from there you can find x is equal to something, right? And that's going to be the value of sine theta. And from there you have to come up with what theta is. Okay, I'm not going to say any more than that. Is everybody clear? Yeah.
Why is it 2 sine theta?
Why is it what? It shouldn't be 2 because I am dreaming about 2, I guess. Okay, there should be just x. Everybody says what he said? I had a negative sine theta originally. I didn't have a negative 2 sine theta, right? So it should be just sine theta, and that would be just x. So I have 2x squared plus x minus 1. So use the quadratic formula to come up with x, and then x will have 2 values, plus or minus, and then you have to find out a theta. So sine theta would be the same as x values, and then come up with theta values. Is that making sense? All right.